It's okay? Okay, ask me question, think. Ask me. No, think, please. I would like to clear it today. Okay, again, what is a capacitor? Okay, guys, where do you use capacitors? In every electronic circuit, right? You use a capacitor to store some charge, right? And how does a capacitor store charge? There are two metal plates, conductive, right? Two metal plates, metal 1, metal 2. In the middle is an insulator. What is an insulator?
GNT.
Yes, what is it?
Not conductive material.
Non-conductive material, right? It's like air or water or polymer. All dielectrics, okay? All of these materials in the middle. So my point is that biomaterials are very complicated materials. You cannot just see them like a resistor. Complicated, complex.
Okay.
Like you are a complex creature. I'm serious.
Okay.
Because if you look inside the human body, it is really complicated, right? So when you think about an antibody, what does an antibody think of you? Like, it looks like a polymer. It's not completely conductive also. So there is some capacitance, right? Why is there some capacitance? Anybody can tell me why when you put an antibody on the surface, there will be capacitance? Why? Double layer. Do you understand? Double layer. Double layer. They don't. I want you guys to tell. Because the main thing is for you guys. You are sitting in the front. These are outsiders. Students. Okay. What was I saying? Forgot. Double layer. Two layers. Look, Candy. Guys. Candy is...
I just don't understand the easy words. I don't know the DC, AC.
Okay,
AC means air conditioner.
Guys, okay, 1 minute, please. Take this concept detail. Does everybody understand what a capacitor is? I know you guys do, but what about you guys? Capacitor.
Explain it to them in Chinese.
Yes. Bernie, can you say it in Chinese? I just said the
这
exact
是那
thing.
个电容是什么？对，
这个我知道，但是我不知道这跟2层有什么关系。
没关系. Don't look at this, okay? Forget this.
Okay.
Just think about
你们觉得电容要
what
干
is
嘛？
this?
电子。
Yes, it's a resistor, right? What is this? You always look at this, but what is it?
那个叫什么？电池吗？就是发电的那个。
How to battery?
Yes.
But battery and capacitor is different. I will not go into the detail of why battery and capacitor is different. They both store charge, but it's different mechanism. Okay? But this is a capacitor. It stores charge. As I told you, 1 metal plate, 2 metal plate. Okay? And what is in the middle? Guys, oh my god. Insulator. Okay? Right? This is how a capacitor looks, and a capacitor is used in every electronic circuit, just like a resistor. You can, Amy is a physicist, he will tell you.
Yeah.
But yes, capacitor. Okay? My point is, this is what a capacitor looks like. Okay? Are we clear? Now, let's go back to our biosensor. You have this. What is this? Electrode surface. Is electrode conductive? Yes, right? An electrode surface can be conductive or semiconductive. Okay? Semiconductor. Chen.
半导体。
Yeah.
半导电。半导电的。然后导电的是
So,
半导电。
look at your carbon electrode. It's not a 100% conductor. 100% conductor is like silver or gold or whatever. This carbon has a lot of polymer inside. It's not 100% conductive. Okay? So it's semiconductive or conductive. Now think about it like this. This is one, where we talk over here, one metal layer. You agree?
Yes.
What is the other metal layer? There is another metal layer. Maybe we put an electrode on top, no? No, guys, think, look at this, the solution. What about the solution? Redox probe, right? Redox probe has ions, right? If you use PBS also has ions, right? But if you use DI, maybe not so many ions, right? So the ions act like another electrode. Okay? Because the solution is conductive.
Oh, okay.
The solution is conductive, so that is one. The electrode is the other, and the biomolecules in the middle are, what are they? Insulating, right? They are the insulators in this case. So, does that look like a double layer capacitor to you? Does it look like a double layer capacitor now? You can think about it. Okay? So, that's why whenever we make, can anybody tell me what is the name of this? We can go more detailed and put W and what is that? Oh, resistance of solution. Okay? But my point is, what is this basic circuit called?
Effect.
It is a circuit diagram, but it has a name. It is the most commonly used equivalent circuit model.
Equilibrium circuit.
Yes, but it has a name because somebody made this the first time, and the name of the person.
Wheatstone bridge?
No, that's not a Wheatstone bridge, guys. A Wheatstone bridge looks something like that.
等一下电路啊，
With
是
different
等一下电路啊。
resistors, right?
中文
By the way, I'm
可是
focusing
我
on you
不知道
guys.
那个人名。
Okay? Here, my point is, look here now. Do you agree that there is some capacitive effect?
Agree.
I need you to tell me properly why you agree. Or tell me.
Because its structure is two layers.
This is how an Indian glass goes.
Yeah.
And maybe something is
How Indian glass goes.
in the middle.
This is in the middle, right?
Yeah,
This,
and
the unpied,
is-
maybe polyaniline. What is
And
that?
is how to say that?
Insulator.
Insulator. Yes.
Insulator,
Yes, and
right?
it's like that. It look like the.
Exactly, look like this, right?
Yeah.
So we agree that there is some capacitive effect. Okay? We agree on that, right? What about resistive effect? It's always going to be there, guys. Any electrode surface is going to have a resistive effect. What is resistive? Which means how difficult is it for the current to flow from one electrode to the other? What
Then
is
again, how is this?
Okay, let's go into
R.
basics, guys. Basics. V, I, R. What is V?
Voltage.
Yeah, what is voltage?
电压。
They give me the answer in Chinese. I'm asking you, what is it? Tell me, what do you think when you think of voltage?
A potential gradient.
That's the right answer, okay. But anyway, what is it? No, no,
说点什么？
you help her to say, what does she want to say?
就是。
Because you guys are using voltage every time, you know that, right? When you do EIS, you put like how much... Okay, how much voltage do you guys use when you use EIS?
你们觉得电怎么来的？
No, guys, I want answers from you two. You are the
EIS
main focus of this study.
The biosensor group.
对，你们觉得电怎么来的？
Good question.
靠呀！
Guys are master students.
Taiwan Electricity Company. Power company.
That is, go Taiwan. That's what you want to
Yes,
say.
it's a great.
动力转换成电这种法，反正是 有变小去输送，不是吗？
半对
我觉得不是。
半对，
对，你觉得不是？明明就是，只是不是上面。
Guys, but this is what I mean, no? Like if you don't know the basics, like what exactly does it mean? Okay, look at it like this. Okay, we think about current. Current, what is current? What is current? Forget this. How does electricity happen? Why does electricity happen? Because electrons flow, right? We agree on that. You agree on that? Okay, let's think about it like water. Let's think electrons are water. Okay? Let's take this mountain for example. The water, let's say there is a how to say, reservoir of
It's a
water.
waterfall.
Yeah, let's say there is water on the top, okay? But by the way, what is water
Waterfall,
like?
Something funny.
I just told you before,
No,
water, let's think water is like electrons.
What do you call a waterfall?
What is electrons?
waterfall，
Yeah.
瀑，
Yeah, well let's imagine that water is like electrons. Let's say this is a mountain, okay? And on the top of the mountain there is water. Will the water flow down? If the water is allowed to flow down, will the water flow down?
Potential.
No, one minute. Yes or
嗯
no?
先不要
If
先
you
不要，
have
太快
water
太
on
快
the。top of the mountain, and let's say you have a wait for the water to go down, will the water flow through or not? Yes, Chloe.
Yes.
Yes.
John,
Yes.
yes,
Oh,
obviously.
when the teacher asks the question, almost 80%, we just say
Yes.
yes.
Candy, yes, I like that.
This class is harder than I thought. Anyway, guys, let's think about like water. So water is like electrons. Why is the water flowing down? Because there is a difference in height, right? Height is the same like a difference in potential. Okay? Yeah, it's a difference in potential. That's why the electrons, when there is a difference in potential, the electricity will flow, right?
有脚架。
Okay, what about current? You can imagine current like a river, okay? This is the Amazon,
电流。
okay? This is the Amazon and this is the, let's say a river in Kaohsiung, the Love River, okay?
Okay.
Current, I told you, is like water, right? So where does, when you think about current, what is the physical
Flow of charge.
flow of charge
He want to
per
ask that.
per second? Yeah, so it's the rate of flow of charge,
Oh, yeah.
right? So it's the number of electrons per second. That is what current is, right? Guys, this is basics. Yes. Now, okay.
Be patient.
Okay, I agree. Amazon and the Love River. Which one has more current flowing through?
Amazon.
Why?
Because it's huge.
Because it's big, right? It has more water flowing through per second. So more current. Anyway, so that is that. And what is resistance? Resistance just means that the current will flow slowly. Okay.
It's like a dam.
It's like a what?
Dam.
Like a dam. It stops the flow, right? That's the resistance. But let me give you a practical example of resistance. Did you know that if there was no resistance, you would have no light? Not these kind of lights, but like
Incandescent.
incandescent lights.
The yellow one.
The
one
yellow
that gets
light.
hot.
Yeah, the bulb that you see.
Yeah, like the filament.
Why? Why does that work? Because of tungsten, right? It has tungsten inside, and tungsten has a very high resistance. So that's why when electricity flows through, it gets really hot because the current cannot flow through. That's why it lights.
You can use bamboo also.
You can use
Bamboo.
how do you, bamboo through.
The first filament was made out of
That's
bamboo.
true, actually. That's true. The first filament, and that was made by Edison.
Yeah, no.
It was because he tried 6,000 different kinds of filaments.
Or somewhere, I
It
forgot.
was Edison. He got that bamboo thing,
Yeah.
natural
Red
material. Maybe maybe.
What do you call bamboo?
It's
The
a
one
kind
that
of
Panda
the
eats.
food.
Yeah, bamboo is a kind of food. Yes. But
Also,
you can
it's
use bamboo to make houses or
I
make
know,
other
yeah,
things,
yeah, yeah.
right?
I just confused why you talk about bamboo.
Oh,
You
he
can
said
make a
that the
bulb
first
out of bamboo.
filament, the bulb looks like this inside, right?
Oh.
The first filament was made using bamboo,
Okay.
some kind of bamboo. But this is related to resistance, right? More resistance, the current cannot flow through, so it gets hot, 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 and then it starts to glow, right? So anyway, so this is the basics of VIR. Now, come back here. Okay, come back here. We agree that there is capacitance, yes or no? Everybody is agreeing. What about resistance? Right? There will be resistance because you have antibodies over here. You can think of the antibodies like this, right? There's resistance there. So there are two things, this and this. What about DC? DC you can only measure R. You cannot measure the capacitance in DC. That is why.
Why we can't measure capacitance?
Good question.
Because R we can measure, and V also can measure.
Yeah.
Yes. and-
By the way, what is the definition? What is the equation for capacitance? Then that will give you the answer. What is the equation? Just simple. 2 C is equal to, I mean,
Q
Yeah,
by
physicist. What
But
is
C
it?
is equal to E epsilon naught.
Epsilon naught A over D.
I see.
D o-
Epsilon.
Yeah, A over D.
A over D.
Yeah.
Right?
absolute
Yeah, yeah.
permeability.
A over D. But guys,
我好像有学过。
these are
Things to-
Constants.
yeah, constants. But my point coming back, your question was why you cannot use DC for you measuring capacitance,
Yeah.
right? Because capacitance in some way is related to the frequency, and in DC there is no frequency,
Okay.
right?
I know.
The frequency, why is there frequency in AC? Because you can see that it's like a wave, it has a frequency, right? It's repeating. If you get one more like this,
This
then
is just
DC is just
current and
current and voltage, that's it.
Yes. Okay,
Right?
okay, I know.
But now, here is the
Current.
interesting part. Are we understanding? A little bit. But now here is the important part, May, is EIS. What is the advantage of EIS? Why do we use EIS? Number one, we agree that we want to also know the capacitance.
Yes.
Okay?
Another
Another reason is what?
Non-destructive.
Non-destructive. How much voltage do you apply when you do your test? Toshavi.
0.1. Eh? Wait.
But chapato. I'm not asking exact.
0.01.
0.01,
Yes.
right?
Scan right.
So how much?
Yes.
10 millivolts.
Yeah,
That is so small. Do you understand the difference now? This is 10 millivolts.
Yes. Scan right.
No.
Scan rate.
Scan rate is different, completely different. This is, what is this? What is 10 millivolts?
That's the scan rate probably, because even in EIS it's in the range of 10 to the power minus 6 volts or something.
No. But I'm saying, what is, you said 0.01
Yes.
volts. What is that? That is not the scan rate. That is the amplitude of voltage you apply, right? How much voltage? Toshao. So you can see the voltage is really, really small, right? But when you do DC over here, when you go, let's say Chen does DC and she wants to do it in this range, you can see that this range is huge. This is all V, okay? And this is what? Milli V. There's a big difference between the two. Okay, so one must think that this is really, really small. So it is non-destructive. So you can do a test without the antibody going into the solution or the antibody-antigen bond breaking because of the electricity, because of the high voltage. Are we clear?
Yes.
Right? Any questions? Till now, we go more into it, but till now, any questions?
Oh,
Anybody?
there's a board coming up.
So you mean
No.
is
Wow, that's nice.
Yeah,
DC
we,
has a high.
it depends on us, but for EIS, we will always use.
Arya.
What the heck? What is this?
Professional whiteboard.
Dia tu lagi.
Yeah.
有没有觉得我们这里越来越窄了？